Good morning, Albert Eagles. It is May the 14th, 2020. I'm going to get started with today's warm-up. Alright, skipping down here to Tuesday, where it says find the area. Remember, when we find the area of something, we are going to do the length times the width. So multiplying two sides. On this one, the two sides they give us are 4 1/2 and 7 1/3. So we end up with two mixed numbers. Just like always, whether it's add, subtract, multiply, or divide, we just want to work in fractions, not mixed numbers. So let's change these by doing times and plus. First one, 4 times 2 is 8. 8 plus 1 is 9. Keep the same bottom number of 2. Bring down the times. And the other one, 3 times 7 is 21. Plus 1 is 22. Same bottom number, which is 3. We're multiplying this fraction, so we'll multiply the top numbers and we'll multiply the bottom. Let's start with the easy one. 2 times 3 is going to be 6, but we're going to have to work this one out separate. So we're going to do 22 times 9. 9 times 2 is 18, carry the 1. 9 times 2 is 18 again, plus 1 is 19. So 198 over 6. We don't want to leave it like that, so we need to make sure that we divide, change it back to a mixed number, or maybe even a whole number. There's no remainder. 6 cannot go into 1. Subtract, we get 1, bring down the 9. 6 can go into 19 3 times, which is 18. 9 minus 8 is 1, bring down the other 8. And 6 goes into 18 3 times, which is 18. 18 minus 18 is 0. No remainder, just like I thought, so we end up with a whole number of 33. So we're going to do 33 millimeters squared. Squared because it's area and we only multiply two numbers. Alright, moving down to our graph coordinates. Okay, before I even start with the pattern, let me go ahead and mark where my first two are. Now you see that it's counting by, it looks like threes because it's a 6, 12, 18, 24, 30, but there's gaps in between, so 3, 6, 9, 12, 15, 21, 24, 27. I'm going to fill these in because I think it would be easier to help us. 9, 15, 21, 27. Okay, so on the first one, we need to go over, remember it's always x and then y, so over then up. So we're going to go over 3, up 6. It's going to go right there. Alright, on the x side, it's going to ask us to add 3. The y, we're going to add 6. So if we add 3 to 3, we end up with 6. And if we add 6 to 6, we end up with 12. So we need to go over 6, up 12. The next one, we're adding 3 again to the x side. So this is going to be 9. And we're adding 6 to the y side. So this is going to be 18. So we're going to go over 9, up 18. And the last one, we're adding 3 again to 9, which is 12. And we're adding 6 to 18, which is 24. So we're going over 12, up 24. Shows our pattern right there. Also another pattern, I don't know if you noticed, but it looks like each one of these is getting multiplied by 2 if you work it in and out. 3 times 2 is 6, 6 times 2 is 12, 9 times 2 is 18, and 12 times 2 is 24. Alright, moving to our 7/8 of 6 and 7/9 of 8. Remember, when we take a fraction of a whole, we are multiplying, so we change both these to multiply. Alright, on the first one, we do not want to multiply a fraction with a whole number, so we need to make this into a fraction, but still make it equal to 6 wholes. We can do that by putting a 1 underneath. Alright, so let's rewrite this. First one, 7/8. Second one, 6 over 1. Now we're going to multiply. 7 times 6 is going to be 42, and 8 times 1 is going to be 8. So we end up with 42 over 8. We don't want to leave it like that, so let's divide it. 8 cannot go into 4. Bring down that 2. The closest 8 can get to 42 would be 5, which is 40. 2 minus 0 is 2, so we end up with a remainder of 2. So our mixed number for 42 over 8 is going to be 5 and 2/8. Alright, the next one, 7/9 of 8, same thing. We're going to put a 1 under the 8. That way it's still equal to 8 wholes, but it looks like a fraction, so it's easier to work with. So the first box is going to be 7 over 9. Second one's going to be 8 over 1. All right, now we multiply. 7 times 8 is going to be 56. And 9 times 1 is going to be 9. Again, we don't want to leave it like that, so let's divide. 56 divided by 9. 9 cannot go into 5, so we subtract, get 5, bring down the 6. The closest 9 can get to 56 would be 6 times, which would be 54. 6 minus 4 is 2, so we get a remainder of 2. Alright, so this one as a mixed number is going to be 6 and 2 ninths. Alright, I haven't seen one of these in a little bit. We're ordering from least to greatest. Okay, so when we talked about this before, one thing I said so you can kind of compare it equally or compare it with the same amount of digits is find the one that has the most digits behind the decimal. So for example, this one has 3, this one has 3, this one has 4, this one has 2. So the one that has the most, and it doesn't mean it's the biggest, but the one that has the most is the 0.0988. Because it has 4, we need to make sure they all have 4 numbers behind the decimal so we can really kind of look at them. So the way you would do that is we're adding zeros to any number, as many as we can, to make sure they have 4 behind the decimal. So in this first one, 0.995, he's just going to need 1. 0.978, it's going to need 1. And the 0.98, it's going to need 2, because it only has 2. Okay, so now I can kind of look at it. Don't look at the 0.0.0.0 because those are all the same. Look at the numbers behind it. Basically 9,950, 9,780, 988, or 9,800. So if we're looking at all of those, the smallest one is definitely going to be this 0.0988. Okay. Alright, so now on the next one, that's really only 988, looking at the numbers behind the decimal. Now again, we have 9,950, 9,780, or 9,800. Just barely, this 0.9780 is the next biggest, or next smallest, I'm sorry. So then we're comparing 9,950 and 9,800. The next one would be 0.9800. I'm not going to put the zeros on there because you don't really need them. Which means the biggest one is the 0.9950. Okay, last problem. We are going to add and subtract decimals, so we're going to line up the decimals. Alright, first one, 24.5. And we're going to line up the decimals, so I do 0.948. There's a lot of unevenness going here, so we're going to fill in the blanks with zeros, kind of even it up. There we go. Alright, now we can add. 8 plus 0 is 8, 4 plus 0 is 4, 5 plus 9 is 14, carry the 1, bring the decimal straight down, 1 plus 4 plus 0 is 5, and bring down the 2, 25.448. And on the other one, we're going to line up the decimals again. 2.3 needs to go on top because we're subtracting, it's definitely bigger. And then 0.7903. Again, a lot of stuff that's not even here. We need to add 3 zeros on this one. Okay, so watch this. Can't take 3 away from 0. Can't borrow from him. Can't borrow from him. Gotta borrow from this 3. This 3 gets to be a 2. 0 is going to be 10, but you're going to have to borrow again from him, so we might as well just go ahead and make him a 9. This 0 again would get to be a 10, but you have to borrow from him, so he's also going to have to be a 9. And this 0 gets to be a 10. 10 minus 3 is going to be 7. 9 minus 0 is 9. 9 minus 9 is 0. We can't take 2 away from 7, so we have to borrow from this 2. It becomes a 1. This 2 gets to be 12. 12 minus 7 is 5. Bring the decimal straight down. And 1 minus 0 is 1. So 1.5097. Remember, the decimals come straight down on these. Alright, so that wraps up the warm-up for today. I went ahead and continued pulling what I was doing with the add and subtract fraction. Again, remember, it does ask for simplest form, but we're not worried about that. We're just worried about getting the right answer. Okay, so I'm going to work through 7 through 15 today, so just these. So again, if you want to stop, pause it where it's at, and just kind of write down the problems on your own, work them all out, and then check them with me. That's probably the best way for you to absorb anything that's going on here. Alright, so the first one. Remember, there's no mixed numbers on these. We're starting them off a little easier. So no times and plus, we're just checking for common denominators. First one, 3/8, put it right here, 3/8 plus 1/4. I'm going to check to see if my small number can go into my big one. 4 can go into 8, so I can keep 3/8. And I need to change the 4 to an 8. I ask myself, what times 4 gets me to 8? That would be 2. So I also multiply the top by 2. 1 times 2. 1 times 2 is 2. Bottom number stays the same, 8. We're just adding numerators. And 3 plus 2 is 5. We check to make sure it's not greater than a whole, meaning the top number bigger than the bottom. It's not, so it can stay as 5/8. Alright, the next one. 7/8 plus 1/10. We see if 8 can go into 10. And unfortunately, it cannot. Now we have to make two new fractions with a common denominator. Now, you could multiply them together and get 80, but there is a small number they have in common, and that number is 40. So let's start with the 8 first. What times 8 gets me to 40? That would be 5. So we do 35 times 5. I'm sorry, 7 times 5, giving the answer out, which would be 35. And then we need to multiply 10, figure out what times 10 got us to 40, which that would be 4. And we do 1 times 4, which would be 4. So we end up with 35 over 40 plus 4 over 40. Bottom number stays the same. We're adding 35 plus 4, which would be 39. Double check to make sure it's not greater than a whole, and it is barely not greater than a whole, but barely is good enough. So we keep it as 39 over 40. Alright, the next one. 2 7s plus 3 10s. We're going to check to see if the 7 can turn into a 10. It cannot, so we need to make two new fractions. Unfortunately, the smallest number that 7 and 10 have in common is actually 70, so we've got to work kind of big here. Start with the 7. What times 7 got me to 70? That would be 10. So we multiply the bottom by 10, have to multiply the top by 10. 2 times 10 is 20. On the next one, what times 10 got me to 70? That would be 7. So we're also going to multiply the top by 7. 3 times 7 is going to be 21. Bottom number stays the same as 70. We're going to add the two top numbers. 20 plus 21 is going to be 41. 41 over 70 is not greater than a whole, so it can stay just the way that it is. Sorry, coffee. Alright. 5 6 plus 1 8. Check to see if 6 can go into 8. It cannot, so we need to make two new fractions. Smallest number that 6 and 8 have in common, you could go with 48, but you're going to have bigger numbers. The smallest one they have in common is going to be 24. We ask ourselves what times 6 gets me to 24. That would be 4. So we're going to do 5 times 4, which would be 20. And we ask ourselves what times 8 got us to 24. That would be 3. So we have to do the top by 3. 1 times 3 is 3. Bottom number stays the same. We're going to just add the top numbers. 20 plus 3 is going to be 23. Again, we check to see if it's not greater than a whole, see if we need to divide it. It again is barely not, but we can deal with barely. We'll keep it just like that. Alright, this looks like it's the last one for adding. We have 5 12ths plus 5 18ths. Okay, first off, we need to see, can 12 go into 18? And of course it cannot. Okay, so we need to think about the smallest number that 12 and 18 has in common. And this is a little tricky because you start thinking, well, what if I have to multiply 12 and 18? But if you can kind of work out, one way you could do this is you could write down 12 and 18 and you could just skip count until you found a match, because the fact that they're both even numbers and there's a 2 and an 8, there's a good chance that they have a smaller one than whatever 12 times 18 is going to be. So you could do it like this. Okay, so the first multiple for 12 is 12. The first one's for 18 is 18. We just said that's not even, so we got to keep going. Next one, if you're counting by 12s, would be 24. Next one for 18 would be 36. Still no match, so we keep going. The next one for 12 would be 36, and I can stop because I noticed that 36 and 36 they have in common. So 36 can be the bottom number. Let's start with the 12. It took me 3 times to get to 36, so if I multiply 12 times 3, I have to do 5 times 3, which is 15. And on 18, it took me 2 times, so I'm also going to do 5 times 2, which is 10. Bottom number stays the same. I have to do 15 plus 10 now, and that is going to be 25. So now with 25 over 36, it's not greater than a whole, so it can stay. Alright, next one. 7/16 minus 1/4. Check to see if 4 can go into 16. It most certainly can, so we can keep 7 over 16. Go ahead and change the 4 to a 16. Ask myself, what times 4 got me to 16? That would be 4. 1 times 4 is 4. Bottom number is going to stay the same as 16. 7 minus 4 is going to be 3. It's not greater than a whole, so 3/16 can stay. Alright, last three. 5/6 minus 3/8. We ask ourselves, can 6 go into 8? No, it cannot. And just like the one above it, we already know what that common denominator is going to be. It's going to be 24. So we start with the 6. What times 6 got me to 24? That would be 4. So we do 5 times 4, which is 20. And the other one, what times 8 got me to 24? That's 3. So we do 3 times 3, which would be 9. Bottom number stays the same as 24. Sorry, subtract. 20 minus 9 is going to be 11. 11 over 24 is not greater than a whole, so you can leave it just like that. Oh, look at this these giving us gifts here. We asked ourselves, can 2 go into 4? Yes, it can. Keep the 3 over 4. Change the 2 to a 4. What times 2 got us to 4? That would be 2. So we also do 1 times 2, which is 2. Bottom number stays the same. We do 3 minus 2, which would be 1. We end up with 1/4. We all know that that is not greater than a whole. And the last one, 15. We asked ourselves, can 4 go into 12? We most certainly can, so we'll keep 5 over 12. And we'll change the 4 to a 12. What times 4 got me to 12? That would be 3. So we do 1 times 3, which is 3. Bottom number stays the same. We just subtract numerators. 5 minus 3 is 2. 2 over 12 is not greater than a whole, although it can be simplified. We're going to leave it the way it is, so it stays 2 over 12. Alright guys, so my plan tomorrow is to continue working on with these bottom ones down here. If you want to go ahead and pause it, so that way you can send me what it is, and then you can kind of double check it with me tomorrow. But I'm going to work through 16 through 25. You can see those right there. However, unless one of you sends me a topic that you would like me to do instead, like Sophia did yesterday with multiplying decimals, I can work through that instead. Alright, otherwise, you guys take care, and we'll see you back again tomorrow.